Today's lesson video will be nice and short because it's just a little half sheet of notes on page 24. So please add page 24 to your table of contents. And here we go. At the top of the note sheet, you're going to see this graph, and we're going to be finding the constant of proportionality based on the graph. So first off, it helps to label your axes, the vertical axis always being y and the horizontal axis always being x, and constant proportionality will always be y over x. Therefore, we can use any of the ordered pairs that we can see from this table in order to find our y over x value. So I tend to use the first point. You can't use 0, 0 because 0 divided by 0 is undefined. So you have to use the first point other than 0, 0. So I tend to use this one here. So our y is 1,800 and our x is 80. Therefore, our y over x is 1,800 divided by 80. And if we divide this, divide by 80, we're going to get 2250. And because the y-axis is money raised, we know this is $22.50 per each ticket that's sold. So for this charity, $22.50 is raised per ticket that is sold. And then part B on the note sheet is saying how much money will be raised if 600 tickets are sold. So we unfortunately cannot use the graph to help us with this because 600 is not on here, but we do know it's $22.50 per ticket. Therefore, $22.50 times 600 will give us $13,500 is raised if 600 tickets are sold. So we're done with number 1 on the note sheet. Now we're down to number 2. So this one just wants us to find the constant of proportionality based on the table. And here we have some fractions in our table. So it's slightly more complicated than the ones we were working on last week. So we have a luxury taxi fees. So remembering that our inputs, the first value here is going to be X, and then our outputs will be Y. So we have miles driven, and however many miles are driven, there is a certain cost. So we're going to find our Y over X ratio in order to simplify it and find the constant proportionality. So I tend to use the first order pair because it's the smaller numbers. So we're going to have 2 over 1/4. We solve our complex fraction by changing this 2 into a 2 over 1 and then multiplying by the reciprocal, the denominator, so it becomes a 1, doing the same exact number to keep it equivalent in the numerator, multiply across, and we'll get 8 over 1. And we want to figure out, what that means. So it means it's $8 per mile driven. And then here it says calculate 2 different ratios to make sure you're accurate, because if you make a little mistake on one and you think that's the answer, but it's not, it's always good to double check. So on our note sheet, let's definitely at least show one more ordered pair. I use the next one. You could use either of these. They should give you the same value, but I just go ahead and use the second one. So we have 12 over 1.5. I've already changed 1.5 into 3 halves. 2 times 1 is 2. Plus 1 is the 3, and then the denominator stays the same. And then we change our 12 into 12 over 1. We multiply by the reciprocal, the denominator, and slide that number up into the numerator to keep things equivalent. We'll get 24 over 3, which simplifies to $8 per mile. So we're done with our little half note sheet at this point, but we have one last thing to do, which is fill in our vocab for constant and proportionality, which is on page 16 of your notebook. You should already have it. This part is already written in for you. I believe you have to fill in the y over x part, so please make sure you're paying attention so you know what you need to fill in that's missing. A constant ratio of y over x in any proportional relationship, often calculated as a unit rate, which is what we were doing on the previous note sheet. So if we have an ordered pair 35 to 7, the y over x would be 7 over 35, and we could simplify that to 1/5. And if we do 1 divided by 5 or 7 divided by 35, we could also change this to a decimal, and it would make sense to change it to a decimal if it was money. This would represent 20 cents. Over here, we have our non-example. So if we do x over y, that is not the constant proportionality, it's the inverse. And so that would be our non-example. And then the thing I chant in class sometimes is y over x, y over x, y over x. And then the joke I have made up is, why are you over your x? Why are you over your ex? Well, because he wasn't kind and he just wasn't the right guy for me. That's why I'm over my ex. And then in class, students worked on the classwork. You can see this file on the Google slide if you were absent and need to make it up.